Hello everyone, today's joke of the day is why do cows have bells? Stay tuned to find out. Our learning target for today is I can identify the correlation of a scatter plot and I can describe the meaning of a correlation in context. Okay, so we're going to be looking at some different ways to represent data called scatter plots, and we're going to talk about how we can describe correlation, okay? So first of all, what is a scatter plot? Well, a scatter plot shows the relationship between a set of data with two variables. Okay, so there are lots of different ways that we can look at data, right? And a scatter plot is one of them. Okay, so it shows the relationship between a set of data with two variables, and they're graphed as ordered pairs. Okay, so in this case, we have in this first example here, we have height and weight, and we have like our weight and our height, and that's graphed right there as an ordered pair. Okay. In this other one here, we would have age. So let's say like 19. So this point here, the coordinates of that point would be 19 and 15. Okay. So that's saying there's a point of data where someone's age is 19 years and the accidents per 100 drivers are 15 for that. Okay. So these can be used to investigate a relationship between two quantities, such as height and weight. Okay, so we would say that height and weight are whatever we're representing in this graph here, or age and accidents per 100 drivers. Okay, so and then these have different types of correlation. Okay, meaning that one variable is likely linked to the other measurement, which would make sense, right? Like weight and height are probably linked because as you get older, right, and you grow, your height goes up, and also so does your weight. So we would say that those pieces of data are probably linked, right? Of course, there's always variation in that. But as you get bigger, as you grow taller, your weight will probably increase. Okay. Also, this graph shows that age and accidents per drivers makes sense. Like 16-year-olds are probably going to get in more accidents than 25-year-olds, just because they haven't been driving as long. Okay. So the correlation then describes how these variables are related. Okay, the correlation describes how the variables are related. So we have some different types of correlation. The first is we have positive correlation. Okay, that means that if we were to draw a line roughly, and the average of these points are kind of in the middle, right? I would draw my line pretty much like that, right? That's going to be a line that best represents our data here, and it's going to have a positive slope. Okay, so it's positive slope. Okay, and a positive slope means we're going to have a positive correlation. Okay, so in this case, as the time increases, okay, the time spent exercising increases, the amount of calories you burn is going to go up, right? We'd say those two things are positively correlated. Okay. Now we could also have a negative correlation. So if I draw my line in here like this, and it goes down, so we have a negative slope, that's going to be a negative correlation. Okay. So this is saying that if you're weightlifting and you are lifting more weight, right? The more weight you lift, the fewer repetitions you can do. That makes sense, right? If you're lifting something that's only 20 pounds, you're going to be able to do a lot of repetitions versus lifting something that's 100 pounds, okay, or more, right? So those would be negative correlated. Now, this scatter plot kind of just shows a lot of random dots all over. There's not really a clear way I could draw a line that would kind of like represent all of the data, because like if I drew like this or something, there's still these points that are really far away from the line. Okay, so in that case, if you kind of have a plot where all the dots are scattered around, we call that no correlation. So this is saying that the amount of books you borrow is not really correlated with your fine in dollars, right? So if even if you borrow 10 books, there's not really a way we can predict what your fine would be, okay? And that's kind of what we use scatter plots for, is maybe for predicting things for a certain amount, okay? But we'll look at that. Okay, so if we have a correlation, okay, let's think about what they mean. Okay, so positive means as x, okay, your x variable, your independent variable, increases. Well, let's look back up here. Okay, here we have our x increasing. What's happening to our y? It's also increasing. Okay, so y also increases. So if things are positively correlated, your time in minutes goes up, then the calories burned goes up, okay? Increases. Negative is the opposite. So as x increases, we always start with as x increases, as our dependent variable increases. Y, okay, our independent, or actually, sorry, as our x is our independent variable, that increases. Then y is our dependent variable, that will decrease for a negative correlation. Okay, so like in this one, the more weight you use, the fewer repetitions you can do. Okay, and then no correlation means that there's no relationship between x and y. Okay, so let's look at a few examples here, and we're going to determine whether each graph shows a positive correlation, negative correlation, or no correlation. And then if there is a positive or negative correlation, we're going to describe the meaning of the correlation in that given situation. So, average jogging speed. Well, it looks like there would be a correlation. I would probably draw a line kind of like that in here. That's pretty close to all the dots, about as close as I can get. And this has a negative slope. So we're going to say that this has a negative correlation. Okay. Now we are going to describe the meaning and situation. Okay, so let's kind of use this as an outline. Negative means as x increases, y decreases. Okay, well, this is our x-axis here. And this is our y-axis. And we're talking about jogging speed. Okay, so a sentence that we might be able to write here is as the number of minutes jogged increases, the speed, or maybe even we could say the running speed, which is in miles per hour. Not that that really matters. We could probably leave that part out. The running speed decreases. Okay, so we followed our outline here. As x increases, so I just replaced x with the number of minutes jogged, which is our x variable, our independent variable, increases, then y, the running speed, decreases. Okay. Let's look at this next one here then. Gas mileage of various vehicles. Now it doesn't really look like I could draw a line here, so I'm going to say that there is no correlation. And if there's no correlation, we can't really describe it in the situation because those things aren't really related to each other. The speed of the vehicle and the miles per gallon, the gas mileage, doesn't really relate. Okay, so we'll just move on to the next one. All right, this one, if I drew in a line here, this would probably be the one that's closest to all of those points. This has a positive slope, okay, as we go up and to the right. So this is going to be a positive correlation, which means that as x increases, y also is going to increase. Okay, so we're looking at free throws and the practice in minutes per day and the relationship to the percentage of free throws made. Okay, so here I'm going to say that as the number of minutes practiced. Oh, that's how I spell practice. As the number of minutes practiced increases, the percentage of free throws made increases. And that makes sense because anyone who practices some sort of sport or even like a musical instrument or something, the more you practice, the better that you're going to get, right? So scatter plots can tell us the relationship between two variables, or they can tell us that they don't have any relationship in the case of a no correlation type plot. Okay. Now forward to today's joke of the day. Why do cows wear bells? Because their horns don't work. Thanks for watching and have a great day.